Skyscrapers aren't as stable as they look. On a windy day, the top of some towers can sway by several feet, not millimeters, feet. So why don't they collapse? These buildings weigh hundreds of thousands of tons. They rise half a kilometer into the air. They're exposed to wind, earthquakes, gravity, and time. And yet they stand for decades. The reason isn't that they're rigid, it's that they're designed to move. Let's start with the obvious problem. Tall things fall over, you've seen it yourself. Stack books too high and they tip. Balance a pencil upright and it lasts a second. The taller something is, the more unstable it becomes. So why doesn't a 500-meter building behave the same way? The first part of the answer is underground. What you see above the street is only half the structure. Before a skyscraper rises, engineers dig deep into the earth, sometimes 30, 40, even 50 meters down. Then they drive massive reinforced concrete piles into the ground until they reach solid bedrock. It's less like balancing a tower on the surface and more like anchoring a ship to the ocean floor. That solves gravity. But gravity is actually the easy force. It pulls straight down, and buildings are very good at carrying weight downward. The real danger pushes sideways. Wind doesn't hit a skyscraper once and stop. It pushes, releases, shifts direction, and builds rhythm. At high altitudes, wind speeds can be 2 or 3 times stronger than at street level. And when that force repeats, something interesting happens. The building begins to oscillate. It rocks back and forth at its own natural frequency, like a giant tuning fork made of steel and glass. Now, here's the surprising part. Engineers don't try to stop that movement completely, because rigid things break. If you bend a dry twig, it snaps, but a green branch flexes and returns to shape. Skyscrapers are designed to behave like that green branch. Their steel frames can bend slightly without permanent damage. Instead of resisting all the force at once, they absorb it, spread it out, and let it pass through. But sometimes flexibility alone isn't enough. So engineers add something remarkable near the top of many tall buildings, a massive counterweight called a tuned mass damper. Picture a steel sphere weighing hundreds of tons, suspended on cables or resting on hydraulic systems. When the building sways left, the weight swings right. When the wind pushes one way, the damper pushes back. It doesn't stop movement, it cancels it. Taipei 101 has one that weighs 660 tons, and during strong storms, you can actually see it slowly swinging inside the tower, silently stabilizing the entire structure. And wind isn't the only threat. Earthquakes send waves of energy through the ground and straight into buildings. If a structure were completely rigid, it would try to resist that energy all at once. That's when catastrophic failures happen. Instead, many skyscrapers in seismic zones sit on base isolators. Thick layers of rubber and steel between the foundation and the structure. When the ground shifts, those isolators absorb much of the motion before it travels upward. The building doesn't fight the earthquake. It rides it. There's one more subtle trick hiding in plain sight. Shape. Modern skyscrapers aren't just tall boxes. They taper, twist, curve, and step back as they rise. That isn't just aesthetic. It's aerodynamic. Flat surfaces allow wind pressure to build, but change the shape, and the wind can't grip the structure as easily. It flows around it instead of slamming into it. Some towers are tested in wind tunnels for years before construction even begins. So when you look up at a skyscraper, you're not looking at something stubbornly resisting nature. You're looking at something engineered to cooperate with it. It anchors deep into the earth. It flexes like a spring. It balances itself with a swinging weight the size of a house. It absorbs motion instead of fighting it. Skyscrapers don't stand because they're stiff. They stand because they're allowed to move, and once you realize that, they stop looking fragile and start looking incredibly intelligent. If that kind of thinking interests you, you're in the right place.